so now we're going to work on creating our own OPUS solution. We'll be doing that in Trimble Business Center. So on Canvas, under this week's module, there's an assignment with the survey file. So this was a survey that was previously collected. And what we'll be doing is downloading that data. We'll be using the processing services under survey processing services in Trimble Business Center. And then we'll basically put all this information in to submit to the OPUS website. So Trimble does this through its own program, Trimble Business Center. Trimble, we use Trimble for GPS surveying. Yeah. And then I'll be posting this lecture. There's a video, it's also on Canvas, that gives you a walkthrough of how to do this. And what we'll end up doing is we'll get this solution back from OPUS that gives us our corrected base station control point location. Then we're going to apply that solution to our survey. Our survey is going to be based off of this really inaccurate base station location. And then we're going to be applying the correction to that to shift everything in the survey, all the points that we took, such that it is more accurate. So let's see here. I think I'm going to do, let's go ahead and watch this.
I'm going to show you how to apply an OPUS solution to a point in Trimble Business Center. There are a few steps. First, you'll need to submit your file to OPUS. In this instance, we're going to use the Trimble Access Services data processing tool, which is available right in TBC. Then you will import your files, both the field files and the OPUS XML solution file. We will adjust the OPUS point quality. We will then rename the OPUS point, and then finally merge the points into one solution.
Okay, so just to kind of rephrase that, what you're working with is a job file. A job file is the job that you set up when you did your GPS survey. Created a new job, right? And then we went out, and we didn't get to do this, but we'll do this next time. If you go out and you collect your survey points, those all get stored in the job file. We took that job file off the controller and we have it on a thumb drive or something like that. Okay. So that job file has all of our surveys, super important. However, that survey is really inaccurate because it's based off of inaccurate base station control point. So what we're doing then is we're taking this OPUS solution, which is an XML file. That file is imported into Trimble Business Center. It's treated as a point. So Trimble recognizes it as a point file with coordinates. We're going to tell Trimble that that point is really high quality. It's control quality. Okay. We will rename it and we'll give it the same name as the point, the base station point from our original survey. By doing so, that tells Trimble to merge the 2 points together. And because it knows that the OPUS solution is a really accurate one, it's going to then merge everything to the more accurate point. So it's just a workflow that we're going to be using in Trimble Business Center. When you have duplicate points with the same name, you have to choose which one you want to go with. Trimble will automatically go with the more accurate control quality. So that's just a setting we can do in Trimble Business Center. You can tell the quality of each point, and there's 3 options, or maybe even 4. But the highest option is control quality, and we use that for our control points.
Let's take a look at how this process works. In the Trimble Business Center home screen, we'll start by choosing the link for Trimble Access Services. In the Trimble Access Services screen that appears, if we do not have an account, we do not need to log in. Simply locate the Navigate to pull-down menu in the upper right-hand corner and change it from Sign In to Survey Tools. In the next screen, you will see 2 tools available. Choose the Data Processing tool. Once the Data Processing tool loads, we are prompted to browse for the file that we wish to process. Choose the Browse button, and locate the file that you want to process on your computer. This would typically be a static T01 or a T02 file that was collected in the field.
That's your base
Once you have
station
your file
file.
chosen, hit the next button, and your file will be uploaded into the
Just to repeat, that's your base station file that you got off of the base receiver via Bluetooth, via your control handheld computer unit.
tool. Now you need to select a data processing service to send the file to. In this case, we're going to choose OPUS Rapid Static and pick Next. Now we'll be able to review the file and make a couple modifications if needed. In this case, we're going to change the point name to number 1, and we're going to just verify that our manufacturer, type, measurement method, and height of our antenna are all correct. The last step is to key in your email address and pick the send.
Okay, so this is super important. What kind of antenna do we use? We used an R8 for our base station. Where do we measure? Well, we measured to the extension arm, right? But we need to correct that. So in this case, we'll have to, maybe that option's in here, maybe it's not. We'll have to make sure we get the right height information input into this. Because right now it says bottom of the antenna mount, in which case we would have to measure to the bottom of the antenna.
But the file will now be sent to OPUS for processing. Once it says that the file has been completed, you can hit reset to send another file, or you can simply just close the tool and start a new TBC project by picking Start New Project from the list. In this example, we're going to use a survey foot template and pick OK. In this example, we're only going to bring in the static file that we collected and not the job file. So here we will first need to set our coordinate system that we want to work in by choosing the project settings icon in the top part of the screen. In the project settings window that appears, choose coordinate system from the left-hand side of the screen, and then choose change on the bottom. Here you can see a list of recently used coordinate systems that we can simply pick, or we can choose coordinate system in zone to pick a new system from a list of predefined systems available.
Now your survey, you set this up when you created your job file. So everything should match. The coordinate systems that you select here should match the coordinate system that you noted when you set up your job file, your survey.
Once we have our coordinate system and our zone selected, we pick next to continue, and we can change our geoid model if needed. Once we are satisfied, we pick finish and OK, and now our project is set to the coordinate system that we want to work in. Then we drag and drop our static T01 file from the field into TBC, and we get the raw data check-in box. Here we can modify things like the point ID, we can check the file name, start time, end time, duration, and we can also double check the manufacturer, the antenna, and the height information before we actually import the file into the project. If we want to import the file, we pick OK, and now our point will appear in the project. Now we want to open the email that we received from OPUS that contains our solution and review the data and make sure it looks correct. Then grab the OPUS XML attachment to the email and simply drag and drop it directly into TBC, and our point will be imported into the project as well. Now you can see we have 2 points in this drawing. We have our static observation in the field, and we have our solution from OPUS. I can do a quick check on these by inversing between the 2 points. And in this example, you can see that they are roughly 7.7 feet away from each other. Now we need to set the quality of our OPUS point to control so that when we merge the 2 together, the OPUS quality or the OPUS position will hold. To do this, open up your Project Explorer and expand the points menu. Here you will see the 2 points listed in the project. And if you expand the OPUS solution point, you will see a little gamma rail symbol showing the position from the imported XML file. Select the XML file on the screen and right-click and choose Properties. In the Properties box, you can choose the icons next to the coordinates and choose Control Quality from the list, and then scroll down to the bottom and choose Close to close the Properties box. Notice now that your point has a triangle symbol around it, indicating that it's Control Quality. You can also recompute the project at this time if needed. Back in the Project Explorer.
That's a nice little thing to note. In Trimble Business Center, whenever you're kind of making adjustments like this, press recompute. It's that little red button down here. It's also available up here. And that just kind of updates, like refresh in ArcGIS.
Right-click on the OPUS point and choose Properties. In the Properties box, change the name to number 1, which will exactly match the imported T01 file. When you do this, you will get a message saying that that point ID already exists, and it asks you what you wish to do. Choose the Merge Points button to merge the 2 points together. Now you will see your field observation merged to your OPUS solution, and you can recompute the project to save the changes. And that concludes our tech talk on applying an OPUS solution to a point at Trimble Business Center. We hope that you found this beneficial and will join it.
All right, great. So let's do that together. All right, so in Trimble Business Center, let's go to survey. And then, let's see here. Okay, so I just went to the, I went to file right here and then tools. And then I'm going to do let's see here. Let's try Trimble Connect. No. Let's see if we can get these windows here. Okay. Survey home. Processing services. There we go. So survey processing services. It brings you to a website. We'll navigate to that folder. So we downloaded these data from Canvas. So it's called CMU Survey Data 2020. Yeah.
Because it's not supported with our current license.
Every fucking time. Okay. I swear. I can only do so much. Let's just walk through it. We're going to find our T02 file. This is the file that we downloaded from the base station. And it has all that point data in it. Okay, so successfully uploaded. Let's go to review antenna information. Here's our survey time frame. It was a 22-minute survey. We had an R8. We called it 0.100. Here's our antenna. This might be important. So there's two different versions of R8, right? So that's something to double check. I'll just kind of keep it as it is. And then we measured to the lever of the 0.15 meter extension, right? So that's a nice option. And then here's the measurement height. This was already stored in the unit, so we'll just kind of run with that. But this is where you want to go back and check your notes, right? What did we measure? Where did we measure to? What was that information? By putting this lever extension, it knows there was an angle, and so it's going to be able to correct for that angle. All right, what processing do we want to do? This is going to be rapid static because we only had about 20-minute survey. Put your email address in. Okay, and then it's going to submit it to OPUS to correct. So I'll get an email maybe within the hour. But we've already done this, fortunately, so we can go do the next steps. So let's go back to Trimble Business Center. Let's go File, New, and we'll call it US foot, US survey foot, and press OK. And then we will import our files. So if I get a home, I can click on import. This is a little funky here. These down arrows will set the properties. So we want to click on the up part. So home, import, and click on this actual folder up here. So it's already in that folder. Let's bring in that job file. The job file again is the survey file that we collected when we did our our survey. In this case, this is a survey we did from last year, just out front of Confluence Hall. So we have the date, right? And then CMU2, so it's collected on the CMU2 controller. So I select that. Hopefully you guys can do this and then press import. And now we have the point. So 100 is our base station. And then this was the CMU2 controller. So we started at 2000 and they went around and surveyed the basically just the front lawn in front of Confluence. You can see that these points are just vectors. They're vectors coming off of that base station. We can go to, let's see here, survey. Oh, it's up here. Let's see. If you look up top, hopefully you can access the coordinate system manager. It doesn't let you do that. Okay, so that's where we're having problems. We'll have to get that fixed. So if you click on coordinate system manager, I'll just do this for the video. You can should be able to check what our system is. Okay. I'm just trying to figure out how we can see where we are. Here we go. Okay, so I'm just going to look at this. I'm going to my project explorer, and you know, I don't think we've saved this, so let's go ahead and save this. So save as. It's going to be a project file, which is .vce. So we'll just call it CMU 2020 survey. Okay, so now we saved it. Right click on that points, properties. Let's see here, points, project settings. And then let's do coordinate system. So you can see that the coordinate system is state plane 83, NAD 83, 12B is the geoid. So that's an older geoid. The information from OPUS is going to be based on the 18 geoid. I think it's going to be okay because it's just going to correct everything to the 18 geoid. So we'll leave that. All right, so that now we have the points shown here. Now we'll bring in that XML file. So let's just go to import. And here's this XML file. This is the OPUS solution that was emailed to me after I submitted it. So let's import that and let's zoom in. Here is the OPUS solution, the more accurate point. Here is my survey point. And so we can look at how far away they are by, let's see here. Let's go back over here. So here's the tutorial that we're kind of walking through all these steps. We just want to be able to compare the points. Average points, merge points, Kogo. Here we go. So if I go to the home tab, I should be able to measure distance. So I'll measure distance and it kind of snaps, right? If you see that little circle right there. Okay, so these points are 3.9 feet away from each other. Let's see here. So horizontal about 3.6 feet, vertical about 0.75 feet. So that's the difference there. Now, if we were to have this set up there for like 6 hours, right? This point's not going to move too much, right? But it's going to be a little bit more accurate. Okay. Now, the next step in the video was we want to take this point right here. This is our solution, right? It's the 100 underscore some weird stuff. It's that XML file. Let's right click on that and then go to properties. And then we should be able to click on this. So this is, this sets the quality of that point. So if I click on this little icon, right now it's under survey quality. There's mapping quality. Mapping quality is going to be plus or minus, meters, right? Survey quality is going to be plus or minus, 5 to 10 centimeters, and then control quality. That's our control. So I only have to do that for the latitude. It does it for lat and long. And then the height, I'm going to do it for control quality for height. All right. So once that's done, we're going to click this little recompute button right here. It's also up here, this little red circle. And we'll save it. So now we've got this control quality. You can see these triangles, and this icon updated to a triangle. Let's click on this. We're going to change the name to 100. That's going to match what we entered for our base station. So I just clicked on that point right there, and then I changed the name of the point ID. Now it's going to say, okay, point 100 already exists. Let's merge the points. So this is where the magic happens. I'm going to press cancel right now. I'm going to zoom out so that you all can see what happens to the whole survey. So I'm going to click on that again, change the name to 100, and then we're going to merge the points. So let's watch closely. Everything shifted. So now we shifted over, and now everything's updated based on that higher quality survey point. All right, let's see if there's anything else we wanted to talk about. Okay, now next steps, we're going to go ahead and recompute the survey. Oh yeah, so that was the other key, right? Everything shifted, the vector shifted over here, but the points didn't shift. When I clicked recompute, the points shift over. So everything shifts X, Y, and Z and is updated. All right, let's go ahead and save that. And now I can export these files. I can export it as a CSV file by selecting all these points. And then I can go to, let's see, export. And I want to export this. I could do GIS. I could export it as a KMZ, a shape file. I could just do point cloud and export it as, hopefully we got a CSV. Let's see, survey. Different formats. CAD. I can export it as a DWG or DXF file. Should be a way just to do it as a CSV file as well. Probably under custom. There we go, trajectory CSV file. That would probably do it. We can play around. You can also do custom, and in this case, it says points, elevation, or easting, northing, elevation, and then code. So this would give you a CSV file right here under custom, and you can change these outputs. And here's the file name. You can change where it's going to save, right? So I can export it like that. I'll go to my Trimble folder, Trimble Business Center under documents. Okay, I'll make sure that works for you guys. And then you can also export as a KMZ file and then open that up into Google Earth and just check it. So some good options there. All right.